We're going to do a doozy of a problem here. Given the graph of a quadratic, also known as a parabola, find the equation. Then we're going to take that a step farther and find out what the vertical and horizontal shift will be, which that's kind of easy to do. But we'll also find what the vertical and horizontal compression or stretch will be. And that's a little harder to do. So here we go. And what I have here is the transformation of a function. So A is your vertical compression, how much it's stretched or compressed. B is your horizontal compression or stretching. C is your horizontal shift. And D is your vertical or up and down shift. So here's our problem. So we have to find out what basically A, B, C, and D are. What are all these shifts in this graph? And find the equation. The easy part actually is finding the equation. And when you look at this graph, some things you should have memorized immediately is that the parent function of this graph is y equals, or f at x equals x squared. So that's our parent function. And if you were to graph y equals x squared, you'd probably have something that looks like this, only much better drawn. So that's one fact you need to have memorized with quadratics. A second fact that I find handy, especially when you're given a graph, is the general form of a quadratic can be written like this. And I'm going to just show you kind of what all this stuff is. But A, in this case, stands for your compression and stretching. H stands for your horizontal shift. And K stands for your vertical shift, your up and down shift. And so with this formula in mind, and also this graph has a vertex of h comma k. Well, what's nice is when you're given the graph, we know the vertex. There it is. Our vertex, in our case, is -3, -4. So we can get our vertical and horizontal shift out of that. And so we can plug it into the formula. So y equals, we don't know the stretch or compression yet, but we do know that it's x minus a -3 squared plus a -4. And so we simplify that, we've got y equals a x plus 3 squared minus 4. So C is 3 and D is -4. So our shift is 3, which would be -3 on the graph for horizontal, and our vertical shift is -4. And I'll probably explain why we switch signs there in just a second. But let's go ahead and finish finding the equation of this graph. Okay, the other thing is, so we need to find out what this A stands for. So to do that, I always pick the easiest point I can find, and this one's pretty easy. That's not the vertex. The y-intercept is 0, 8 in this case. So I could plug that in to find A. So we're going to plug 0 and 8 into our function to find out what A is. So if we do that, we would go 8 for y equals 0 times, not 0, sorry. 8 equals A, that's what we're trying to find. You plug, it's x comma y. So you plug 0 in for x, plus 3 squared, minus 4. And so we'll go ahead and solve this thing now. So 8 equals A times 3 squared minus 4. You could go ahead and add 4 to both sides. And so we have 12 equals a times 9. And then you'd keep solving it. Hopefully, I'm not doing anything new here, so I'm going to divide by 9. So I know a is 12 ninths, or if we reduce that, 4/3. So we know the equation of this thing. So y equals 4/3 x minus or plus 3 squared minus 4. So that's one way of doing it. And if you needed it in the general form of a quadratic, well, you just go y equals 4/3 x plus 3 times x plus 3 minus 4. And so y equals 4/3, and I'm just going to quickly distribute. This is what I'm doing. So that's x squared plus 3x plus 3x plus 9 minus 4. And you keep going. And so y equals 4/3 x squared plus 6x plus 9 minus 4. Distribute the 4/3. So y equals 4/3 x squared plus 6 times 4/3 is 24/3 or 8x. 9 times 4/3 is 36/3 or 12. So plus 12 minus 4. And so we'd have an equation of 4/3 x squared plus 8x plus 8. So that equation is the same as this equation in its two forms. So one's called standard, one's called general form. To me this is standard form, this one, because it's standard form of a polynomial. This one is the general form of the quadratic. And so if all you need is an equation, you're done. And I think that's a pretty quick and nice method to do that. But we've got to move on because we've got to know what this horizontal and vertical shift are. So first off, we need to kind of have we already kind of talked about this, but there's a horizontal shift warning. If you have x plus 3 in your function, or x plus c, that translates to an actual point of x minus c. So if it's positive here, it shifts left. If it's negative in the function, it shifts right. So one way I always do, like we know our shift is a -3. It went left 3. So our horizontal shift would look like this, because I always set them to 0 and solve them. So if you solved this, x plus 3 equals 0, you subtract 3, and so it's -3. An actual shift of -3. So our c is +3 in that general form. So looking at our form, what we have, first off, we know f at x was x squared. And so we know that if we plug this in with everything we know, where we know c is 3, we know d is -4, plugged directly into this formula. And so when we do the composition of functions, g at x looks something like this. A, which we don't know yet, we kind of know, times f at b times x plus 3 minus 4. Well, we know what f is, so now let's plug that in. So we know that our function is x squared. So we know this then would become a times, and I'm going to use brackets, this b x plus 3 substitutes in for the x in our function. And so we would have b times x plus 3 make sure you got the right number of parentheses, squared. I'll close my bracket because I've embedded my function there, minus 4. So let's simplify this just a little bit. Or let's pause. Okay, so there might be some fancy formula for this, for finding A and B, but we already know what the quadratic equation is, and I think that's a fairly easy task to do if you practice it. So we're going to use that easy task to figure out this A and B. And so we already found out that we had 4/3 x plus 3 squared minus 4, which if you notice, we're really close to the same form here. That means A and B have to multiply somehow to get us 4/3 pulled out there in the front. So we know we're going to have a 1/3 probably, or a 2/3, or maybe a 2. And so let's just try it, just play around with it a little bit. And so let's just assume for a minute A is 1/3 and B is 2. And then let's just see what happens. So if you were to do that and let A be 1/3 and B be 2, and the reason I put the 2 there is because we need a 4. We need a 4 on top. So 2 squared is 4. So what we have here is 1/3 times 4, and then x plus 3 squared minus 4, which 4 times 1/3, we can go ahead and multiply these out. Now that we've squared it, we can multiply those. So 4/3 times x plus 3 squared minus 4. So yes, indeed, A is 1/3, which is my vertical shift, and B is equal to 2, which is my horizontal shift. Or, sorry, compression, not shift. I probably said that a few times incorrectly. But yeah, so A is my vertical compression. So in this case, we stretched it by 1/3 vertically, but we compressed it by 2 horizontally. And actually, if you look at the definition for horizontal shift, what you do is you divide all of your x values. If you have your original parent function, you would divide all your x values by b and multiply all your y values by 1/3 to get the correct compression out of the graph. And so that's probably more than you would ever need to know. Maybe. I don't know what you're doing, but I feel like He-Man after solving that. So very empowering to learn this math. And I guess one final thing is we could talk about just the graph and what it looks like to shift this thing around. So if you go over here to Geogebra and just play around with it. So this is the function a times x minus h plus k, just to kind of show you what happens. So as a increases, that's compressing and stretching your graph. If you flip it, you go to negative. H, notice a positive 1.3 over here is an x minus 1.3, so it's a right shift. It's a shift right of 1.3, but in the function it's x minus 3 for that horizontal shift. And then k, if you shift that up 1, you just add 1 directly here. And so that's kind of a nice little thing you can play with just to kind of understand what's going on. And all I did to build that was I added sliders and there's the function. So you add the sliders first, and then you type in the function f at x equals a times parenthesis x minus h squared plus k. So that general form again. And there you have it. And I hope this helps. And I will definitely and hopefully see you next time.